Ingesting to open standards is really a very good idea these days. We're seeing more and more MXF about. It's being more and more widely adopted by the industry. We certainly support MXF as do most other vendors these days. But be a little bit careful. Norbert mentioned it earlier, test these systems. Our flavour of MXF may not be quite the same as somebody else's flavour of MXF. Within that MXF, there's a whole load of metadata, there's a whole load of indexing, there's a whole load of video and audio tracks. And if they're not all 100% compatible with the destination device, then it's not going to have compatibility and it's not going to be able to play. So be careful and check. There are standards, but they're very open, and there's different interpretations of those standards. So it may be that one vendor may not have implemented one part of that standard and another vendor has. So really my best advice is to test and get those files to those various vendors and see if they really are compatible before you put your money down and build one of these systems. Next, I want to talk a little bit about APIs. I'm going to talk more about those at the end of this section. But being able to get and put metadata into a video and audio file, associate it with that media asset, is typically a good idea. I want to talk a little bit about the different types of metadata. There's, of course, the rich user metadata that drives the workflow processes and drives the user processes that Serena's talked about. But there's also a lot of technical metadata as well. That technical metadata has always been there, things like in and out point and duration. But of course, that can be extracted back out again and can be useful for the media asset management purposes as well. Just how long is my clip? Just where is the in point? Can be useful for driving other processes for transcodes and for playout and so on later on. Another feature of an API is to report from the server system when a new file arrives. As we move into more and more file-based workflows, we're not necessarily ingesting video streams. We may be delivered with just a file that arrives on our server. That may be pushed to us rather than us demanding that it gets pulled to us. So supplier of video X supplies it to us as a user, but they just push it when they're ready. Having notification of that and giving that notification back from that server platform to the media asset management system can notify it when it's there and available, and then can trigger the next part of their process. Another key feature of these types of system is what we call active transfer. I mentioned latency earlier. Active transfer is a term that we use for being able to access that file as it's growing. And active transfer can mean being able to edit whilst recording, being able to play whilst record, being able to transfer while record. All of these things are going to be critical in time-critical type workflows. Being able to play whilst ingesting is important for QC and for the file-based QC. Again, you may not be able to have the time to wait until that file is closed on ingest before being able to QC that. If you're QCing in real time, you may want to start just a few seconds after the start of that ingest. Certainly HD and SD systems are prevalent out there now. As much as we'd like to see everything HD, we still do work in mixed environments. So having a server platform that can work with both and be able to play out both types of material on the same timeline may be a key advantage. And finally, having a proxy available at the time of ingest, along with the high-resolution video, is going to be important for these MAM-type processes, for some of these QC-type processes. Having a low-resolution proxy allows you to have multiple users all accessing that clip at the same time, without the heavy load of using the high-resolution video and audio. Currently, we're using MPEG-1, but we're seeing more and more MPEG-4 or H.264 being used for proxy. One of the key drivers for that is for the same bitrate as an MPEG-1 file format, you get a lot more resolution. And that can be really critical if you're trying to look for those players on that wide shot, see who actually kicked the ball and be able to identify that number on the back. I've certainly been involved in a number of tests where actually the resolution you need for the low resolution is nearly as high as the high resolution. Certainly for SD, you can get up to similar bit rates as SD for your proxy preview. Something worth keeping in mind when designing the network and designing the storage systems around this.